Today we will be in Chapter 4, Section 3, Slope of a Line. Our two topic objectives for today are to find the slope of a line and to examine the slopes of parallel and perpendicular lines. Chapter 4, Section 3, Slope of a Line. Slope. A ratio of the vertical change to the horizontal change between 2 points on a line. That sounds like a lot of hoopla, but if you think about like just the slope of a ramp or anything like that, like it really is just the change of how much you're rising over how much you're actually like going in distance. So if we were just looking at the picture that I put on here, and we're just going between these 2 points, how much height are we going here? What is that? Well, we have to start at our bottom point and we go up 1, 2, 3, 4. So our vertical change was 4. But then how far over did we go? What is our horizontal change? 1, 2. Okay. So what is that? That might not tell you anything. So let me write it out here. Slope equals vertical change over horizontal change. So in this case we had a vertical change of 4 and we had a horizontal change of 2. So that means we had a slope of 2. Now that's kind of the mechanics of how it works, but that's not really how you're going to use it. You're not going to sit there and count on your graph. We have an actual slope formula that you're going to use, and so that is y2 minus y1 over x2 minus x1. And slope is usually abbreviated to an m. I know that's weird. I actually don't remember why it's abbreviated to an m. It's just abbreviated to an m. Now the x2 and the y2s and all that, that's for 2 separate points. So you have an x1, y1 point, and you have an x2, y2 point. So up here on our picture, we could have used this formula in order to figure out that our slope was 2. Oh, yeah, that's right. What we could have done is this point right here, our bottom point, was actually the point 1, 2, and this top point was the point 3, 6. 1, 2, 4, 5, 6, yeah. So we could have used those 2 points and used this formula in order to solve it. And what that would have been then is y2. Now it does not matter which of these is your second point as long as you keep it together. But I'm going to do the bigger one. So y2, so that'd be 6 minus our y1, which is 2, all over. And then the x2, we have to do the same one that we did our 6 with, so that'd be our 3 minus 1. So 6 minus 2 is 4, 3 minus 1 is 2, and that reduces down to 2. So we still get that our slope was 2. So you can do it with counting. Don't recommend that. You need to memorize the slope form, the slope equation. Okay, let's do an example. You're going to find the slope through -6, 1 and 3, 5. Okay, it does not matter which one of these you designate as your x1 and your y1. It really doesn't. So I'm going to try and keep it positive, and let's just use this one as our x2, y2 because the 5 is bigger. So our slope, m equals y2 minus y1 over x2 minus x1. And if you're wanting to memorize this little equation, the best way to do it is to write it down every time you use it. Because then you're gonna write it down so many times you're gonna know it by heart. So our y2 is our 5 minus our y1, which is 1, over 3 minus a negative 6. When you minus a negative, that turns it into a positive. Remember, negative times a negative is positive. So that'll give us 4 on top and a 9 on bottom. Does 4 go into 9? It does not, so our slope in this case is 4/9. Okay, we'll do another one. Let's find the slope through the points -2, 1, and 3, 4. So m equals y2 minus y1 over x2 minus x1. So we have 4 minus 1 equal over 3 minus a negative 2, so it'll be plus 2. 4 minus 1 is 3. 3 plus 2 is 5. And just to show you that it does not matter which one of these you do first, I will do it again with this one as our x2 and our y2. So instead of doing 4 minus 1, we would have 1 minus 4 over -2 minus 3. So that would give us a -3 over a -5. But when you have a negative divided by a negative, that's going to give you a positive. So it's still going to give you 3 over 5. So it does not matter which one of these you do, you're still going to get the same slope because you're still dealing with the same line. Okay? So that's how you're going to find slope. Now, in general, you have positive slopes and negative slopes. The graph on the left is going to be a positive slope. If you're looking at this line, you're going from the negative end, like if you start on the left, to the positive end. If you start on the left part of your x values, these are your negative x's, and your positive x's are over here, and your line is going towards the positive x's. So this is a positive slope. If you ever see a line that looks like this, you should instantly know it's a positive slope. And that's a great way to check your answers when you're finding your slope, because a lot of times you can lose your negatives or get them mixed up, and so this is a great quick check. So if this is a positive slope, then this is a negative slope. If you're starting from the left, you're going down. You see that? In this case, we're going towards the negative y's. On the positive side, we're going towards positive y's, positive x's. Over here, we're going towards negative y's. This is a negative slope. This isn't a big deal or anything. It's a nice quick check. Okay. Now, the next thing we're going to talk about is slope of vertical and horizontal lines. These are, the vertical and horizontal lines are always kind of special. So how do you find the slope of those? So the first thing I want to do is I just want to plot this so you can kind of see the lines, or the line, excuse me. We have 2, 5, so go over 2 and up 5. And then we have 6, 5. So we have a horizontal line. Now let's find the slope of that using our equation. M equals y2 minus y1 over x2 minus x1. So our y2 is 5, our y1 is 5, and then we have 6 minus 2, So 0 over 4. 0 divided by 4 is going to be 0. And hopefully that makes sense. You don't have any type of a slope here. You don't have a ramp in this case, you just have a flat floor. And that is always the case. Horizontal lines always have a slope equal to 0. Always, always, always. Okay, so if that's a horizontal line, then let's look at a vertical line. Example, we have 2, 4, and 2, 1. One, 2, 3, 4. 1, 2, 3, 4. Okay, so let's plot these points. We go 2 to 4 and 2 to 1. And it's not going to be a perfectly vertical line, but there's our line. Okay, what would you think the slope of that is? Hopefully that's a little bit of a confusing question because it doesn't really make sense, and I will show you that. M equals y2 minus y1 over x2 minus x1. So our y2 is 1 minus our y1, which is 4. And then we have 2 minus 2 on bottom, so we have negative 3 divided by 0. And right there, hopefully, red flags go up. Are we ever allowed to divide by 0? No, we can't divide by 0, so that means our slope is undefined. And that means vertical lines always have an undefined slope. Our slope is our vertical change over our horizontal change. But if we have a vertical line, then there's no vertical change. So that's why that is the case. Those are two questions that usually come up on the final in some form or fashion. So it's something that you might want to make extra note or star or something just to keep your eyes peeled for that. Okay, so we've been dealing with just one line at a time, but we are about to embark on a new, area, and we're going to deal with parallel and perpendicular lines. Parallel lines run side by side. Perpendicular lines intersect at a 90-degree angle. And for the cases of these notes and this class, parallel lines will be indicated by these two slanted lines. And perpendicular lines will be like this upside down T, because they intersect at a 90-degree angle, which is what these are. Okay. Parallel lines have the same slope but different y-intercepts. And we'll do an example so you can kind of see what I mean. But in your homework, you're going to have to identify whether two lines are parallel, perpendicular, or neither. And so if you're able to look and just see what the slopes of the two lines are, and you know they're the same, then that tells you that they're parallel. So it's a really quick check, actually. Okay, so here's an example. And then there's the graph. And it says draw a line with a slope of 1/2 through the point 2, 3. And then it says we're going to draw a line with a slope of 1/2 through the point -1, -3. And then we need to know if these are parallel. Based off of what I just told you, you should automatically know that these are parallel because they have the same slope. but we're still going to graph them so that you can see that. Okay, so how do you graph this when we don't even have the equation? The way you do it is we're going to plot the point that they gave us, so the 2, 3, which will be right here, and then we use our slope to tell us which way we go. Now remember, slope is vertical change over horizontal change. So our vertical change is a positive 1. That means we're going to go up 1. So we need to go up 1. And then the bottom is a 2, and that's our horizontal change, which means, and it's a positive. So positive, you go to the right on horizontal. So it means we go up 1 and to the right 2. And then you plot your other point. So this is how you use a point and a slope in order to graph your line. And in this case, since we don't have an equation, that's very nice. So let me graph this. And again, I do apologize if my lines aren't perfect. Hopefully your lines aren't perfect either. Okay, so now we got to do step 2, which is draw the line of -1, -3. So -1, -3, right there. Again, we're going to use the slope of 1/2. So that means we have to go up 1 and to the right 2. 1, 2. And plot our second point. So are those lines parallel? Yeah, they're a little shaky, but hopefully you can see that they're parallel. They lie right next to each other, and the thing with parallel lines, besides the point that they have the same slope, parallel lines will never intersect. They will never cross each other. You can draw this line out for 5 miles, and it's never going to cross this line because it's going as high and as far as the other one is. That's the importance of the slope. If this one were to rise faster than it were to run, then it would eventually bump into this one. But because this one goes up and over at the same rate that this one goes up and over, it's never going to cross. So those are parallel, and those are parallel lines. Okay, so let's do perpendicular. Perpendicular sound a little harder, but they're really not. Perpendicular lines have slopes that are negative reciprocals of each other. And that's kind of a mouthful, but you've seen reciprocals before back in chapter 1 whenever you were dealing with fractions. You had to know the reciprocal in order to find out like the multiplicative inverse of the fraction. And in order to divide by fractions, you had to do the reciprocal. So you have seen this before, and I will remind you of that. So if it tells us that the slope is 5, the negative reciprocal of that is going to be a negative, and then you're going to flip your 5. So remember, 5 is the same thing as 5 over 1. So if we need to flip that, that would be 1 over 5. So the negative reciprocal of 5 is negative 1 over 5. So what would be the negative reciprocal of negative 1/2? Well, this one already has a negative. So if you put a negative out there, that would make it a positive. Negative times a negative would be a positive. And then you flip your 1/2, which would be 2 over 1, which is the same thing as 2. So the negative reciprocal of negative 1/2 is positive 2. Okay, slope is 4 over 7. The negative reciprocal of that would be negative 7 over 4. Let's do an example. Okay, we're going to draw a line with a slope of -3 through the point of 2, 3. So let's plot the point 2, 3. Go 2, 3. And then we have a slope of -3. So remember, -3 is the same thing as -3 over 1, which would mean our vertical change would be -3, so that would be going down 3, and then to the right 1, because the 1 was positive. So let's plot that. So there's our first line. Now our second line said -1, -3. So -1 and then down 3 right here. And then it has a slope of 1/3. So that means we're going to go up 1 and to the right 3. 1, 2, 3. So are these perpendicular? Yes, they are. And hopefully you could have seen that just based off of the slopes, because -3, the negative reciprocal of that would be positive 1/3. But I wanted to graph them in order to show you. Now, one of the problems you're going to have on your homework is going to look like this, where it's going to say, determine if the following pairs of slopes are parallel, perpendicular, or neither. And then you're just going to have the slopes. You're not going to have anything else but the slopes, and so you have to determine what they are. So if we're looking at A, we have slope of the first line is 5/6. Slope of the second line is 5/6. So what does that mean? Is that parallel, perpendicular, or neither? If the slopes are the same, then that means the lines are parallel. Okay, let's look at B. The slope of the first line is 2/5. The slope of the second line is 4. Is that parallel, perpendicular, or neither? That would be neither. And the reason for that is because they don't have the same slope, obviously. And if you flip and negate the 2/5, you're going to get a -5/2, which is not 4. So those aren't perpendicular. Okay, let's look at C. We have the slope of the first one is 3/5, and the slope of the second one is 5/3. Are those parallel, perpendicular, or neither? I'm sure some of you just said perpendicular. I don't know because you're not here with me. But that would actually be wrong. These are neither. And the reason for that is they're both positive. If one of these was negative, then it would be perpendicular. But these are both positive, so that means these are neither. Okay, so then looking at the last one, hopefully you know what it is. Those would be perpendicular. So a very easy check is if you have two slopes given to you and they're both either positive or both negative, but they're not the same, then your answer is going to be neither. Because the only time you can have slopes that are of the same sign, like both positives or both negatives, is if they're going to be parallel, and then they have to be the exact same. If not, then one slope has to be positive and one slope has to be negative in order for them to be perpendicular. So it's kind of a quick check, or a quick way to check that. All right, let's go get your homework open.